Hello, everyone. Thank you for joining us for today's session, an interactive session for startups. Unlock the power of Cosmos DB from MongoDB vCore. My name's Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask you please be mindful of your commentary, remain professional and on topic. Keep an eye on the chat. We'll be dropping links and answering questions. We'll also have time for questions during our session. Our session is recorded. It will be available on demand within 24 to 48 hours, which brings us to today's session. I'll turn it over to our presenters now. Thank you so much for joining us.
Hi, everyone. Thanks for joining us today. My name is James Cadella. I'm a product manager at Microsoft in Azure Cosmos DB, and I'm joined here by my colleague, Kaylin. So today we're going to talk a bit about unlocking the power of Cosmos DB for MongoDB vCore. So utilizing Cosmos DB for AI-powered applications, and really why, we'll be showcasing a couple examples why Cosmos DB is the best transactional database for your AI-powered applications. So just a quick agenda for today. So we'll talk about what are the unique requirements for AI-powered applications in this modern era. We'll talk about why Cosmos DB is a great fit. Before we get into the details around AI applications and vector search and all that good stuff, we'll give a brief primer about the concepts. Then we'll dig into Azure Cosmos DB for MongoDB vCore. What is it? What are the great features and how you can use it to power your large language models and AI applications. Then we'll show you a preview of our Copilot in Azure Cosmos DB. This is our brand new functionality for generating Cosmos DB NoSQL queries from your natural language questions about your data. We have some great links for you and some resources to get you started. And then we'll follow that up with a Q&A and answer any of the questions that you have during our presentation. So I'm going to kick it off here to Kaylin. Kaylin?
Hey folks, as we all know, everything changed a year and a half ago when when OpenAI released ChatGPT. People started to realize what they could do with their data, which they never realized before. Modern applications and intelligent workloads have unique requirements. They want data that we get is highly variable and it's unstructured. We get it from different sources like images, videos, and studio, and a lot of things. Also, people users want real-time, fast, always on digital experience while being distributed all the time, right? It looks like we are trying to solve multiple problems and we might need multiple services. Actually not. James, do you think we have a solution for this?
I think we may have something that the team has worked really hard to develop and to deliver.
Let's take a look at it.
Cool. Yeah, so as Kaylin was mentioning, Azure Cosmos DB does it all. It's an AI-ready database where we are used to power AI applications. We use AI to make our database even more scalable and more performant for you. We have guaranteed performance at any scale. Essentially, for Cosmos DB, you can scale to as much compute as you want and as Azure has. And we guarantee 99.999% availability, regardless of the scale. We guarantee for Cosmos DB NoSQL under 10 millisecond point reads, again, at any scale. We have a tremendous flexibility and efficiency. So for Azure Cosmos DB NoSQL, the ability to scale up near instantly, and then also the ability to scale down when your demand and your traffic decreases. Very unique feature to Cosmos DB that saves you money, saves you costs, and is really great for handling dynamic workloads. Oops, sorry, my slide is not cooperating here. Great. Yeah, so as I mentioned, Azure Cosmos DB is AI ready, right? It's an all-in-one solution. So as Kaylin's going to talk about, for our Azure Cosmos DB for MongoDB vCore product, you can do vector search and vector indexing in your database with all of your traditional data, right? You don't need to set up a second vector database or a separate vector database and worry about data sync and ETL to your vector database. You can actually do your vector operations and your traditional transactional database operations all in one product. And this saves you cost, saves you complexity, manpower for managing resources. And with this, you can power real-time AI applications, right? You have all your data in one place, one source of truth. Again, you don't have to worry about data syncing and consistency. You have all your data available as soon as it's ingested, ready for powering your AI applications. So we have built-in native support for vector indexing and vector search in 2 Cosmos DB offerings. Cosmos DB for MongoDB vCore and Cosmos DB for Postgres. For our NoSQL API today, we say you should integrate with a service like Azure Cognitive Search, which is now known as Azure AI Search, to do the vector indexing and vector search. But coming soon, we will have native vector search for our core NoSQL API, enabling very high performance and elasticity, really great for multi-tenant applications. So we'll have native vector search support in Cosmos DB NoSQL as well. And as you may know, OpenAI is built on Azure Cosmos DB. Cosmos DB has been used for ChatGPT chat history in multiple scenarios to power ChatGPT for ages. As ChatGPT has scaled to incredible usage, and as you may know, ChatGPT is one of the fastest growing, fastest adopted applications in history. As they scale to a huge, millions and millions of customers, they didn't have to make any changes to their Cosmos DB instance, right? Cosmos DB scaled efficiently, silently, without any intervention to enable ChatGPT to be really, such a success and have a great experience for the customers. So we talked a little bit about why Cosmos DB is so great. Before we get into some of the details of how to bring your data in Cosmos DB to your AI-powered applications, let's go over just a couple basic concepts. You may be familiar with a lot of these, but so we'll just touch on them pretty lightly. So first, let's start with retrieval augmented generation, or RAG, right? So it's really a way of how to intelligently get the right data from your database to ground or provide context to your large language model, so it knows how to answer questions, right? So models like GPT 3.5 and GPT 4, they're a huge and wonderful tool. They have a lot of sort of built-in knowledge from the data that it was trained on, but they don't know about your specific scenario, or they may not know about your specific use case, right? So if I am a e-retailer, the GPT models don't know what I have in my product inventory. They don't know what I have available to my customers or any description data. So I want to be able to bring that data to my large language model, so that way it can answer questions in a more effective and efficient and accurate way for my use cases. And so to do RAG, there's multiple ways of doing it. A method that's extremely popular today and very accurate is by using vector embeddings and performing vector search, right? So vector embeddings, you may be aware, they're a compact, semantically rich representation of your data. And the idea is that you have some data, maybe data describing a product, and you can create a vector embedding using a model or an API service. And you create this vector representation of your data. And this allows you to search for other embeddings or other products that are semantically similar. And the semantic part is determined by the model that creates the embeddings. And the similarity or closeness is measured by some distance function like cosine similarity. So traditionally, we're looking at 5-10 years ago, it was quite laborious to create your own vector embeddings. You had to train some AI model, some deep learning model maybe, or you had to use a traditional sort of embedding method that maybe wasn't as performant. And it was actually a quite rigorous effort to do this. Now it's actually quite easy, right? You can use numerous sorts of APIs, like for example, Azure OpenAI has the Ada 2 embeddings that you can generate text embeddings, and Hugging Face library also has a wealth of different models that you can explore for generating embeddings. So it's become incredibly easy to generate embeddings from your data today. So the applications and ease of use for vector search have really skyrocketed in the past few years. And I mentioned the use of vector embeddings for RAG and for powering large language models. There's a lot of different use cases for vector embeddings, right? So again, like for answering questions, like we had just talked about, bringing your data to ground large language models to answer questions about your data. But it could also be used in multiple different areas, like for anomaly detection, right? So if I have IoT sensors and I'm worried about are there anomalous readings in my sensor data, I could create vector representations of my sensor data and look for anomalies or vectors of my sensor data that are far removed from the clusters or areas of data that I would expect. Vector embeddings are also used for recommendation systems, making personalized recommendation systems about or recommendations about products, about items, anything really you can think of. And they're often used for powering searching, search content in search engines, right? So Bing relies on vector embeddings of images and related sort of data when you do, say, Bing image search or Bing multimedia search. So really a lot of different use cases for vector embeddings for different applications. Today, we're going to spend our time talking mostly around question answering and powering of large language models with RAG. So I mentioned vector search, right? So the idea is I have a vector or I have a question from a user and I want to find the most similar documents in my database in Cosmos DB that are, the documents that are most similar to that user's question. And so when I do a vector search, I would need to build a vector index in my database. And today there are two vector indexes supported by Azure Cosmos DB for MongoDB vCore and Azure Cosmos DB Postgres. The first is the IDF index or inverted file index. And you can think of this as sort of a way of doing clustering and doing like a clustering analysis, like a nearest neighbor sort of search against the clusters. And this is usually pretty fast for building an index and memory efficient. It requires a clustering step before the indexing, which sometimes can be a little bit slow. And tuning the parameters of the index is important. So IDF is usually pretty good if you have a relatively small scale or you're just sort of starting out and you're not sure really like all the parameters you have to tune, or you're not really sure about the details of your scenario, but you're building a POC. We've also launched the HNSW algorithm for vector indexing in Cosmos DB for MongoDB vCore. And this is hierarchical, navigable, small world algorithm. It's sort of a mouthful, but the idea is that it builds a multi-layer graph with long and short connections between the vectors. And so HNSW tends to be very robust, highly performant in terms of the queries per second or vector searches per second. So really good at throughput and also being quite accurate at scale. It also tends to be relatively robust compared to IVF, right? So if you're doing insertions or deletions, it tends to be a bit more robust at keeping the structure of the graph. And so your results sort of maintain consistent accuracy or relatively consistent accuracy over time. So it supports many inserts and deletions efficiently. The trade-off is, there tends to be a larger memory footprint. So maybe you need more computational resources to leverage this. But internally, we've done lots and lots of testing on HNSW and IVF, and we're able to support a scale of millions and millions of vectors with very efficient search accuracy and efficient performance. So I'll hand it over to Kaylin to talk a little bit more about Azure Cosmos DB for MongoDB vCore.
Yeah, we're really proud to announce a newest member of the Cosmos DB family, which has a completely different form factor, which is based on a cluster form factor, which allows you to scale up and out efficiently. That is our Azure Cosmos DB for MongoDB vCore, which is a fully compatible MongoDB database service for building like modern applications with like familiar architecture. With Cosmos DB for MongoDB vCore, developers can enjoy benefits of like native Azure integrations, low total cost of ownership, and have the familiar vCore architecture when migrating existing apps or even building new ones. We're also proud to announce we just introduced the free tier, which gives you 32 gigs of storage, which is 64 times more than you'll find anywhere else in the market. We also introduced burstable queues. We have an option to have new cluster tiers and storage queues. We provide features like private link, and we also have easy migration from MongoDB to MongoDB vCore. Not just that, vCore is AI ready. It includes native vector search along with IVF and HNSW indexes that James just talked about. It is built into the engine. So it's not built on a separate node, so you don't have to pay extra or move your data around. Therefore, your data, your embeddings, and your vectors, along with your vector indexes, is built right into the database. Therefore, you can do your RAG patterns efficiently. And I'll be demoing one of our RAG pattern applications where I build a chatbot without writing a single line of code. Also, we provide plugins for Langchain, Semantic Kernel, and LlamaIndex. Additionally, we have easy integrations with Azure AI Studio, which I'll be using for my demo. If you want to learn more, please visit aka.ms/try vCore. Also, KPMG Australia, an early adopter of generative AI, wanted to build a private, highly secure AI assistant with a conversational interface. The solution would help employees surface insights from unstructured data. And during this development process, they switched over to MongoDB vCore, and they noticed a significant difference. Their search quality jumped from 50% to 91%, and the results were being delivered in like seconds. They have also noticed like 50% jump in productivity across multiple domains. And also they were able to like scale it to all other KPMG member firms. Let's get into the demo of how we can build a RAG pattern application without writing a single line of code. Let me share my screen. Right. So we have our GitHub repo. We'll have the link for it at the end of the presentation, where all you have to do is, before we go into the demo, I want to explain the solution architecture of how these RAG type applications work. So we have our Azure Cosmos DB for MongoDB vCore, where we are going to store a source data along with the vectors. So how it works is we send our original documents to a vectorized function which calls the Azure OpenAI embeddings model, which then converts those data into embeddings to store it into our database account. Similarly, we have a front-end application when users get to ask the question. So when they ask a question, the question is converted into vector embeddings, and then we do vector matching by going into a database and looking for the answer. And once it finds the answer, it's going to send it back to our database and convert it into English so that users can understand the answer. Additionally, we're going to store prompts and like completion into our database to give an even personalized experience to our users next time when they ask a question. So you just go to this GitHub repo, and all you have to do is click on deploy to Azure, and it's going to deploy to an Azure account if you have access to an Azure subscription and you have subscription to Azure OpenAI service. For the sake of the presentation, I've already deployed it, and this is how it's going to look. So once you have your deployment ready, all you have to do is go to the Azure OpenAI Studio, click on it, and let's wait for it to load up, and then click on bring your own data. Before we go on to the next step, I'm going to show you how the data is stored in a database. As you can see, we have our database called Retail DB, and in our database we have a collection called different collections like completion, customers, products, and sales orders. For this demonstration, I'll be using the products collection because I want to build a chatbot which is going to recommend our users bikes and its accessories based on their needs. So if you click on a collection, we can see our regular data, which has the category name, which has the SKU, which has the name as well, the description, and the price. And additionally, we're going to have the vectors right here in the database. So this vector representation is this representation is basically the representation of the data that we have over here. Additionally, we have built-in indexes. For this demonstration, I'll be using the HNSW vector index, which is also built right into the database. Again, everything is right under one roof. So you can build your applications using Azure Cosmos DB for MongoDB vCore. Now, let's go back to our building a chatbot. So the first thing we want to do is select a data source. I'm going to use MongoDB vCore. I'm going to select my subscription and the database that I want to use. Database account. I'm going to use the Mongo Canada Central, enter my password, hit next. select the database, which is going to be the retail DB. The collection I'm going to use is products. And the vector index I'm going to use is the vector search index, which is basically the HNSW vector index. And the embeddings model that I want to use is the Azure OpenAI embeddings model. You can also use Hugging Face on Azure, which has integration, which we have easy integrations with using vCore. And the content data that I want to index on is the category name, the name of the product, the price, the SKU, and the description. And I'll be using the vector field, which is the vector embeddings field that I have in my database. And now we just hit save and close, and we have our chatbot ready. So let's ask the question. Hi, what is your name? As you can see, we got a very generic answer saying, hi, I'm an AI assistant trained by OpenAI and hosted on Azure AI platform. But we want to make it even more personalized. We want to make it personalized to our product or our website. Because if you have a personalized website, you can share with your customers and bring your brand closer to them. So I'm going to give my chatbot a personality. I'm going to name him Wheelie. I'm going to say, hey, your name is Wheelie. You're an AI assistant for the Cosmic Works bike store, and you're going to help people find product information for bikes and accessories. I want you to be playful and friendly when answering questions. Also, I'm going to look at the advanced settings, change the strictness to 1, and reduce the number of retrieved documents to 3. Additionally, I'm going to change the max response to 200 words because I would like to have it like a shorter answer instead of giving me a whole list of answers. Okay, now let's ask him a question again. Hi, what is... Also, don't forget to save your system messages. As you can see, our chatbot has a name now. It says, my name is Wheelie, and I'm here to assist you with any bike-related queries you might have. One cool feature that I want to share about this OpenAI Studio is you can enable text-to-speech. You can talk to your chatbot, and you can have it talk back to you again. So I'm going to select my resource, the speech resource, click Acknowledge, enable speech-to-text, and enable text-to-speech. And today I'm going to give it the voice of Brian and hit Save. Now let's try this again. Hi, so I live in Seattle. Recommend me a bike for hilly terrains and rainy weather. And we hit Next, hit Enter.
Sure thing. For hilly terrains and rainy weather, I'd recommend a touring bike. They are designed for long distances and can handle a variety of conditions, which makes them a great choice for Seattle's hilly and rainy environment. One option is the Touring 1000 Yellow 54. This bike is priced at $2,385 rounded up to the nearest dollar. Touring bikes are typically sturdy, have larger gear ranges, and are built for comfort over long distances, which should serve you well in Seattle. Dock 1. Remember, it's always important to try a bike before you buy it to ensure it's the right fit for you. Happy biking!
Thank you, Wheelie. That was a very descriptive answer. As you can see, Wheelie was able to recommend me a bike based on the description I entered, like the hilly terrains and the rainy weather. It gave me the name of the bike along with why it is a good fit for Seattle. As you can see, it says touring bikes are typically sturdy and they have larger gear ranges and are built for comfortable long distances. So, and this is what chatbots are built for. One other cool thing is you can look at the code and basically copy this code and put it in your application. The code is ready for you. And it's in different languages too. It's in Python, we have JSON, we have C#, and we have Perl. All you have to do is copy the endpoint and the key and copy it to your code and just enable it. One cool thing we also have the speech-to-text feature right here in the code. So you can enable speech-to-text when building your chatbots for your users or for your customers. All right. James, I know you're in New York. Do you ride a lot of bikes in New York?
I don't personally, but I imagine that it's riding bikes in New York City could be potentially dangerous, but also a lot of fun. But I'd love to see if Wheelie can recommend something for the streets of New York.
Okay. Hey, Wheelie, I have a product manager on my team with me in this presentation. He's from New York. Now recommend me a bike for him. Let's see how Wheelie does.
Absolutely. For a New Yorker, I'd recommend a road bike. They're perfect for city commuting and can handle the hustle and bustle of New York streets. One option is the Road 750 Black 48. This bike is priced at $540 rounded up to the nearest dollar. Road bikes are typically lightweight, fast, and designed for paved surfaces, which makes them a great choice for city commuting. Doc 2. Just like before, it's always a good idea to try a bike before buying it to ensure it's the right fit. Enjoy your ride.
As you can see,
Cool.
Wheelie was able to recommend a bike based. It's extremely lightweight because he knows that people in New York, they travel with their bikes on the train, and they have to walk up and down the stairs. So I was able to recommend a bike which is lightweight, fast, and easy to pave on surfaces. What do you think of this recommendation, James?
If I had this recommendation before, maybe I would have ridden a bike already in the city. So this is great. One thing I also really love about this is it gives a link to the document, right? So I can see a reference, I can see the bike that it's referencing, right? This gives sort of a traceability or sort of source of what Wheelie's coming up with. So I can sort of validate that, hey, it's not just making things up, it's actually looking at my data and showing me the evidence.
Yeah, it's really cool. Now, I know we have this chatbot ready, but I don't think you can be able to send it to your users or your customers, right? So we have a feature called deploy to, where you can create a new web app. Basically, name the web app that you want. I'm gonna call it Wheelie, and I'm gonna select the subscription that you want to do. I'm gonna go with our subscription we have at Cosmos DB. I'm gonna select the resource group, and I'm going to select the location depending on where you're located. And then I'm going to select the pricing plan, and we have a free pricing plan. So basically, you won't be charged a single dollar when you deploy using this service. And you want to enable chat history, because if you have a chat history enabled, we will be able to provide a better RAG type application, because we can store your previous questions and your previous answers in the chatbot. So when you basically how ChatGPT works, when you ask it a question, it's going to store that in the database, and when you ask it a question again, it's going to recommend based on your previous questions and previous answers. It's even more personalized when you're building such kind of RAG type applications, and you want to acknowledge the web services and everything. So for the sake of the presentation, I'm now going to deploy this right now, but it usually takes like 10 minutes. But all you have to do is click deploy. And once you hit deploy, you're going to have something like this. You're going to have a basic web app where you have the chat interface, the chat text field, you have the logo, the name of the website, and you also have the chat history right here. So let's ask him a question again. Hey, what is your name? Well, let's try that again. Well, this is a demo. Like if it doesn't work in the live presentation, then how can it be a demo? So it should work. It should give you an answer, and I'm giving you an answer that my name is Wheelie, and I'm here to help you with bike assistance. Let's try this. Let's try this one more time.
That's always the fun of having a live demo, Caitlin. What I do love about this interface also that you're showing, though, is like the chat history on the right-hand side that I can see that I'm keeping in Cosmos DB. So as Caitlin mentioned, like chat history is really powerful, right? So if I'm a returning user to this chatbot, I wanted to know what we talked about yesterday or last week. I want to see what we had talked about, right? It's also important for, if you're building applications in a domain where you need traceability and auditability, right? Especially in like finance, especially in healthcare. You need to be able to sort of audit, look at your customer conversations. And there's a lot of use cases as well for driving insights, right? What kind of questions are your customers asking about the data? How are they interacting with the chatbot? How can you use this to make an even to enrich the experience for the customer? So there's a lot of great use cases to both enrich the customer's experience, but also insights for your own organization as well.
Yeah. Also, one other thing I want to point out, we also have the share feature where you can basically share your chat app. You can share your chat app just clicking on share and copying the URL and sending it to your user. But I still don't want to send this website to my user. I want to make it even more personalized. So I'm going to give my chat application a name, a logo, which I just created using Dolly, and its name is Wheelie, just to make sure this is not related to Clippy that Microsoft released a few years ago. So let's try this again. Hi, what is your name? One thing I want to point out is that we also changed the logo over here to a Cosmos DB logo and call it the Cosmic Work Bike Store. So this chat application is like personalized for based on your needs, and you can share this with your users and have it interact with them and give them recommendation based on things that they're looking for. As you can see, we have our chatbot ready right here, which says, "My name is Wheelie, and here I'm here to assist you with all the Cosmic Works Bike Store." So it's basically the same thing that we did Azure AI Studio. We just build it on a website, which you can share with your customers. And even if you ask the same question, like, "Hi, I live in Seattle, like recommend me bikes based on the hilly terrain and all that stuff," it's going to go into the database, look for the answers, and then send it to you right over here. Now, this is a chat application where I've built without writing a single line of code. And now I want to show you how you can build one with a few lines of code using a Jupyter notebook and how you can revolutionize an AI-driven like advertisement field. So for that, I'm going to switch over to my second demo of the day, where the code is available on aka.ms/adgen. All you have to do is click on the repo, copy the code, copy the Jupyter notebook, and have your example.env file ready with all your connections, like the OpenAI endpoint and the key. Let's walk through the Jupyter notebook and see how it works. For the purpose of the demo, I've already installed all the prerequisite packages like the NumPy, the OpenAI extension, and everything. The next step you want to do is just get your configuration from the examples.env file and store it in the database in the application for like further use. So I'm going to hit run. That was ready. And now I'm going to create embeddings. Just an example, I'll create an embedding for like shoes for San Francisco weather. And I'll be using the text embeddings ADA 002, which is the Azure OpenAI's embedding, which is integrated with Azure Cosmos DB for MongoDB vCore. As you can see, we have our embeddings right here for shoes for San Francisco summer. Now let's connect to our MongoDB vCore account. All you have to do is hit enter, and let's look at our MongoDB database. Looks like we are connected, and we don't have a database we don't have a collection or a database in our MongoDB cluster. So let's set that up right now. Let's name our database Adgen database and have a collection called Adgen collection. And this is collected. Now let's go back and hit refresh. As you can see, we have our Adgen database and we have the Adgen collection. We don't have any data right now, so we'll be importing data from a JSON file, and we will be working with it. And I want to, and for this presentation, for this demo, I'll be using the IVF vector index. For the first demo, I use the HNSW index. So as you can see, we have access to both the indexes, and you can use either one of them based on the application needs and what you're looking for. Now let's upload our data from shoes with vectors.json file. As you can see, it took like 1.4 seconds, and the data was inserted into our MongoDB database. Let's hit refresh. Click on the collection. Good. All right. As you can see, we have our data right here. We have the regular data, which is the name of the shoes, the price, and if it's on sale or not, and the color, along with the purchase URL. We also have our vectors stored right here in our database, which is named content vector. And again, as I said earlier, we also have the indexes right built into the database, which is the IVF vector index that I'll be using for this presentation. So we have inserted our data. So now let's do a vector search on it. Let's create this function called vector search. And this code was written in using Python, just letting you guys know. And now we can perform a vector search on shoes for Seattle sweater weather. And as you can see, the first the first shoe that it recommended is the Nature Breeze Rainforest Women's Stylish Buckle Strap Winter Shoes. And it gave me the price and the similarity of how close it is to the question that I asked it to. And we have like around 5 different results based on the similarity along with the image and the purchase. Now let's make it even friendlier. Let's try to have a website where you can see all these recommendations and share it with your customers. I'll be using DALL-E 3 and GPT-4 to build my application. I'm going to give it a personality. I'm going to call it Healy, which is Wheely's younger brother, and it is an intelligent assistant for generating like witty and captivating taglines for online advertisement. So the whole purpose of this application is to build like websites to have like online advertisement for shoes. All you have to do is just provide a few keywords, and Healy's going to take it for you. It's going to create an ad campaign with a tagline is going to be pretty short, and it's going to be under 100 characters. And the user prompt is going to be like to generate a catchy, witty, short sentence for an advertisement for selling shoes for the ad topic that you enter in our website. And we'll be using DALL-E OpenAI key to generate the image that we are looking for. Now let's run this. And as you can see, it's going to show us the product title, the price, the description, and the link where you can buy that shoe. Now let's put everything together and have a website. Let's press enter. And as you can see, we have our website running locally at this server. As you can see, we have a very basic website where we just have to enter the ad keywords that we want to generate the ad for, and which is going to help Healy to create that ad for you. So I'm going to ask it, shoes for Seattle. Let's generate that. So it's going to go into the database and look for shoes that are suitable for Seattle weather. And it's going to bring back us the list of shoes that you can buy along with a catchy DALL-E generated image for our website.
Yeah.
As you can see, we have our Seattle skyline in the background and like shoes used, which were generated using DALL-E. We also have like 5 different shoes that you can that you should be able to buy for Seattle weather. The first one is the Columbia Women's Red Mid Waterproof Hiking Shoes, and we also provide you the price and the name along with the brand, and we have the image generated right here. One cool thing is you can even click to buy the shoes just by clicking on the Buy Now button. Once you click on Buy Now, it takes you to the website where you can find the shoe and buy it for you. So it is stored right in the database, the URL and other stuff. Now let's try to build something for James, who is in New York. I know the weather in New York is completely different than the weather that we have in Seattle. So let's search for.
Yeah, it's cold right now, maybe about 28 Fahrenheit. So maybe something for cold weather.
Let's do footwear for cold weather and cold weather in New York. Let's generate an ad for New York.
Perfect. And it's important to note also that like the vector search that's happening right now happens like in a split second. Like it's incredibly fast. Most of the wait time here is waiting for DALL-E to generate the images and come back with the response.
Yep. As you can see, we have our Statue of Liberty in the background and the winter cold weather of New York and the boot that it recommends us. And also it has a very cool tagline for your advertisement website. As you can see, New York chill, warm up with our styling winter shoes. This might sound a bit cheesy, but this is what gets. These are how these advertisements are built. You can even change the sensitivity to give you a better prompt based on what you're looking for. As you can see, the first boot it recommended was the Bootly Round Tee Leather Winter Boot. And we have a bunch of different recommendations for New York weather. What do you think, James? Do you like any of the shoes? I know this website was built for women's shoes. What do you think for your wife? Would you recommend buying any of them from here?
Yeah, that top one or bottom one looks pretty warm. Looks pretty good. I like the overview picture as well. Although I'm not quite sure where in Manhattan you can stand to get that view, but it's pretty impressive.
Right. Now we covered the West Coast. We also covered the East Coast. Let's do something for a central zone, Texas. Let's do footwear for hot summers in Texas. Now let's generate an ad for it, and let's see if it's able to come up with something very similar. All right, we have a bunch of flip-flops and sandals for Texas hot weather, which is very different from what we got from when we recommended recommended footwear for New York, because New York has a lot of like cold weather. It's like pretty cold right now, versus in Texas, it's like pretty like 90s, 80s, like 80s kind of weather. So if you look at buy now, as you can see, it's going to take us to the website, the Birkenstock website, where you can just click on purchase and get to it. So this is our demo of using by changing the advertisement game by using Azure Cosmos DB for MongoDB vCore and creating like an AI-driven platform for users to use.
Yeah, really powerful example there. And it's so cool to see how well the semantic representations of both the question, even though it's really short, and the descriptions of the shoes, how the OpenAI embeddings model is able to capture that semantic representation and sort of fill in the blanks and realize the relationships there to bring you the right shoes, right? That's really, really amazing.
It is. You can find all the code like at aki.ms/aggen and get started with it. It's pretty easy to get started with both of the demos. You just need to, the first one, you just need to click hit deploy, and it's going to deploy for you. And the second demo that I just demoed, you just need the Jupyter notebook and the endpoints from OpenAI, and you're good to go. All right. I know you have a very cool feature that you want to talk about, James, which I use a lot when I'm working on my PM data and like writing queries. So let's get into it.
Yeah, cool. Thanks, Killen. Great demo. Yeah, so I'm really excited to share with you today something that we've spent a lot of time developing. It's Microsoft Copilot for Azure in Cosmos DB. This enables you to ask questions about your data in your natural language and have Copilot generate Cosmos DB NoSQL queries for you right in the Data Explorer experience in the Azure portal. It's powered by state-of-the-art Azure OpenAI large language models. Your data and usage is private and secure. None of your usage data or none of your data stored in Cosmos DB is used to train any AI model. It's kept private. There's no information shared with OpenAI. Everything stays secure within Microsoft's own ecosystem. And we've also developed it with Microsoft Responsible AI principles, ensuring that that the large language model that powers the Copilot doesn't sort of go off the rails or hallucinate or generate any potentially harmful content. We spent hours and hours doing testing and iterative work to develop it with these responsible AI principles. So I'd like to share with you how this works, and let me show you a quick demonstration here. So I'm going to cut away from the slides, and I'm going to maximize my my window here. So right now I'm in the Azure portal, and I've selected my test Cosmos DB resource. I've gone over to the Data Explorer, and I can see the welcome screen for Data Explorer that we all know and love. And I see something new here. I see a Query Faster with Copilot card that I can click on, and will take me to the sample data set where I can get started and learn how to use the Copilot. Or I can just jump right into one of my own collections and start asking questions about my data. So let's do that. I have this movie data set here. So I'm going to create a new SQL query to run some queries against this data set. And I can see the query editor that we are all familiar with, but now I can see this new pane here above, which is the Copilot pane. And so I can ask a natural language question about my data, and it'll generate a query for me. So
James, do you mind like zooming in a little bit?
Oh, sure.
I want to learn. I want to learn more about this demo, and it's pretty hard for me to see it right now.
Sure, and zoomed in a little bit there. So let's
yeah, that's good.
Perfect. Thanks. So let's do this. Let's ask it a simple question like, show me the first 10 items in my collection. And what I'll do is I'll hit the generate a query button, and this will spin up a separate instance so it keeps all my data safe and secure, and it will generate a query for me. And so I can see here down in the query editor an example. So it tells me, here's the prompt that you entered. Here is the query that gets generated. And then here's a natural language, easy to understand explanation of the query. And I can go and execute that. And I can see the results down here in the results pane like I would expect. So this is pretty cool. Like I can see the results down here. This is a pretty simple query. Select top 10 star from C. Let's see if we can do something a little bit more complex. So maybe I want to know what movies have James Bond in the overview that were also shot in France, and only show me the movie name and the year it was produced. So I'll ask Copilot to generate a new query for me. I'll give it a second, and then there, I can see my prompt, I can see the query, and I can see an easy to understand explanation here. And this looks about right, so I'm going to go ahead and execute the query. And I can see that a couple results were returned here. If I can scroll down here, and I apologize because my window is so zoomed in. Let me try to edit this. I think maybe I need to zoom out a little bit to be able to do this. There we go. So now I can see that there are a couple examples here that I've returned. A View to Kill and Moonraker are the two movies in my collection. I know there's been more James Bond movies shot in France. I think there was a scene in GoldenEye that was in France, but that's okay. All that means is that that movie isn't in my collection. So this is really cool, right? This is a great example of how generative AI can be used to improve your workflows and improve your work efficiency here. And if I want to give some feedback to the Copilot team, I can give a thumbs up if I think it's great, and I can give a thumbs down if I think there's some room for improvement. So I'm going to give a thumbs up. I'm going to give a little bit more details, and I'm going to say, great job, team. Like, this is really cool. So I'm going to send some feedback back to Microsoft. They'll have my description, I'll have the query that gets generated and my prompt, and then the team will use this, and we'll see it, and we will determine, is there anything we can do to make the experience even better for you? Again, the AI model is not trained on any of your data or the schema of your data in your collection. This is just reviewed by the product team. So I'll go ahead and submit that. And great. So that's a quick overview of the Microsoft Copilot for Azure in Cosmos DB.
It's want to find out, James, we also have the copy query thing right next to the feedback button, which I use a lot. Like, I know I'm from the Gen Z generation. Like, I know like how difficult Gen Zs have like when they want to like write queries using like the Cosmos DB queries. So having this Copilot feature is really helpful because we are able to translate like natural languages or English into like Cosmos DB queries and make our applications even better, or even answer questions that our customers have. And the one good thing, like you're gonna mention, like it's completely free, right? You can get access, like anyone can have access to it right now. You don't have to enable any subscription or like do anything with it.
Exactly. Yeah. So Copilot will remain free always in the Data Explorer experience. And right now, Copilot in Cosmos DB is a preview experience. So to enable it, let me just show you here. What I have to do is I have to enable it using the preview features in my subscription. So if I have admin privileges to my subscription, I would click on my subscription. wait for it to load, and then I would just go down to the preview features here. I would let this pane load, and then I would search for Copilot. And then I would find Microsoft Copilot for Azure and Cosmos DB, and I would make sure I'm registered for that. And that's all there is to it. So give it a try. Let us know what you think. Send some feedback. I'll be happy to hear from you. So let's go back to the presentation here. Cool. And Kaylin, do you want to talk a little bit about our Azure AI Advantage offer?
Yeah. So this is a surprise for all of us. Thank you for being in this presentation today. We want to thank you for participating, and we want to help you get started with Azure Cosmos DB. So we're gonna give, for every customer using Azure AI services or GitHub Copilot, they can get up to 6,000 words of Azure Cosmos DB for free for 90 days. Learn more by visiting aka.ms/Azure AI Advantage blog, and you just have to sign up using a form, and you can get started anytime. And along with free tier, like Azure Cosmos DB for MongoDB free tier, you can combine those two features, and you can get started building your AI applications for almost free of cost. And the good thing about free tier is, I know there was a question in the chat, do you get all the features with free tier? Yes, you do. You get most of the features and literally all the features that you need to get started for building your AI application. So I would really recommend checking on these two links and to get started building your AI application.
Great. Yeah, this is a great offer. So happy that we're able to provide something good for our customers.
Right.
And I think we have just a couple of resources to share with you as well. So if you're interested in anything that we've showed here, we have code samples up on GitHub. The Copilot's available for you to try. Sort of going down the list here, aka.ms try vCore allows you to get started with MongoDB. Cosmos DB for MongoDB vCore's free tier. The second link here links you to the demo that Kaylin had shown for Wheelie. You'll have to create your own persona and Wheelie assets, but there's a quick deploy button, as Kaylin showed you, to get started. For the AI advertisement demo in the Jupyter Notebook, aka.ms/adgen. We also have a simple RAG pattern done in Jupyter Notebook. So pulling your data from Cosmos DB, from MongoDB vCore, and interacting with the GPT 3.5 model, all from a Jupyter Notebook. Really easy to get started. Check out that link. And then a link to our blog post about Microsoft Copilot for Azure and Cosmos DB. And then, that great Azure AI Advantage offer that we just talked about a minute ago. So a lot of great resources here to get you started. And if you have any other questions, you could always feel free to reach out. So I think that concludes our presentation here today. Are there some questions in the chat? I'm happy to, Kaylin and I are happy to spend a little bit of time and answer some questions that pop up.
Also, before we end this presentation, I want to thank one other person for helping us with this presentation. And also one other thing, I've watched Age of Ultron, Avengers Age of Ultron, multiple times, and I've watched a lot of sci-fi movies. So I'm just saving myself for the future. So I want to thank Wheelie for helping me with this presentation. You can leave the Learn More slide on for people to take a look at it and check it out. So I'm going to thank Wheelie today for helping me with this presentation and for people for showing up. So thank you, Wheelie, for helping me with this presentation. Let's see how Wheelie responds to my message. And I hope everyone's able to hear this. Oops.
I think Wheelie might be a little shy.
Wheelie, it's fine. It's just us. You don't have to be shy. Right, let's try this again. Wheelie, it's okay. It's nothing to be shy about. There you go. Thank you, Wheelie.
All right.
All right. Thanks, folks.
Thanks, everyone. So let's see if we have a couple questions here. I think we can see. Let's see here. He is shy. He's nervous. Wheelie is a little bit nervous. That's right. So let's see, this question from Jay. Do you think we'll have support for MongoDB or other APIs for Query Copilot? Excellent question. We will have support for other APIs. It's in our roadmap. I don't have an ETA for you right now, but it's a common question that we get, and we're planning on bringing more Copilot goodness to more of the Cosmos DB APIs as well. Maybe while we're waiting for some more Copilot, yes, absolutely. Let's scroll up in the history a little bit, and we'll see some questions here. Let's see some comments about the demo. Yep, great. Does the recommended bike have fenders? I don't know. I need to. That would have been a good follow-up question for Wheelie. So let's see. Let's scroll up here a little bit. I'm building a RAG pipeline, which is built on vector data and metadata filtering. Does Cosmos DB support metadata filtering? So Cosmos DB for MongoDB vCore today supports metadata filtering or vector search. The combination of the two is coming soon. Again, I don't have an exact ETA, but we're working really hard. It's a high priority item for us. We're working hard to get that for you as soon as possible. I also see a question here. What is the difference between vector and a simple model, a record, or class based on some partial view of the JSON document? So yeah, so a vector, right, is a representation of some data. So imagine that I have a document, and maybe, and to take Kalen's example, I have a document that describes a shoe, right? So I have different properties that describe it. I have a name of the shoe, I have the brand of the shoe, I have some descriptors or tags of the shoe, then maybe I have a text description of the shoe. And so what I would want to do is I would want to maybe take the description of the shoe and create a vector embedding using the Azure OpenAI API. And then that vector embedding, I can add back to my document as another property. So I can have a description vector property, and I can treat it as any other property in Cosmos DB. But when I build my vector index, I would point the index to that property and say, hey, like this is where my vector is. So when I do my vector search operations, the vector search knows where to look. So good question. Let's see if there's anything else. Is there a recording available for future reference? I believe that this is recorded, and we'll have a link to share out, so you can refer to it and watch it whenever you want. Right after the stream, the team's working fast. Nice.
Wow. Okay.
Cool. We'll hang out for another minute or so. Any other questions, comments, feedback? I did see one feedback about the query editor. I wish the experience of Data Explorer was a little bit closer to what we had in SSMS. We hear you. We are working on some improvements to Data Explorer. Stay tuned for some goodness to come that way. Cool. I think that's about it for the questions. One more thing pop up here. Let's see. Copilot question. How does at scale deal with 500,000 documents added to the Azure Cosmos DB collection daily? So Copilot interacts sort of as a separate service that sits on top of Cosmos DB. So you can generate queries based on your collection, based on your schema. The schema is sort of identified in near real time. So if you add additional documents to your collection, Copilot should be able to understand what the schema is of those documents. It shouldn't have any problem dealing with large volumes or anything like that. Really, it's the query execution that happens on your data after the fact. But good question. Is Power BI smart of vector queries? So I believe that you should be able to, whatever data source that you hook up Power BI to, if it has a vector search capability, you should be able to construct some sort of query or view to empower your Power BI dashboard. I haven't tried it myself, but there really shouldn't be anything sort of prohibiting you if you can already construct, regular queries using Power BI.
I think we're right now at a lack of questions. Hey, everybody, it's Jay, but I want to ask you, please put some more questions in the chat. We'll be here for a little bit longer. James, Kilon, thank you so much for doing such a great job.
Thanks, Jay. Thanks, everybody, for tuning in and watching the live stream.
And thanks, Anna, for killing it here. We appreciate it.
Thanks, Anna.
Thanks, Anna. If I could give a clapping emoji in StreamYard, I would do it.
I guess I'll ask a question. I'm not going to put up my ugly mug because I'm not in the mood to show my face right now. So you'll just have to hear me. Actually, Christoph with another nice comment for you all. Yes, that was absolutely fantastic. James, do you want to talk a little bit about how you were able to ensure that, one, you're using kind of ethical AI practices in building that query Copilot? Because I think that that's a really, really big part of building AI forward applications now.
Yeah, it's a great question. So we evaluated Copilot on a couple of different dimensions. And when I say evaluated, really it's like an experimentation, right? So you have a set of test cases and you want to see, does your large language model application pass these test cases? And if not, then you make some tuning and you do this sort of iterative testing. And so there's sort of multiple dimensions of testing that we do. So we do what's called red team testing. And if you're curious about this, you can find some details on the Microsoft Responsible AI page. There are some great details about how to do red team testing. But essentially, there are different categories of responsible AI harms that AI models could exhibit. And so what you want to do is get a diverse group of people together from all sort of different technical expertise and design expertise and product expertise and people with a lot of different backgrounds and expertise areas together, and try to think of, for each potential area where a large language model might generate something harmful, what are some examples that you would want to send to the large language model, and you would want it to respond in an appropriate manner, right? So you wouldn't want your large language model to be biased in any way, especially around race or gender or like these sorts of things. You wouldn't want it to generate some code that could be harmful or not optimized or these sorts of things. So we did a slew of testing, using thousands and thousands of different test cases for our responsible AI harms. And what we would do is we'd run our tests, evaluate how well Copilot performs, and then we'd make some small improvements and run the tests again. And we'd do this iterative process over and over again until we converged at a level of performance where we feel confident in releasing a great product for our customers. So that's for the responsible AI part. And there's another part around like accuracy, right? Does your large language model application give you the answers that you would expect? Does it give you correct answers? Or in the case of NoSQL syntax, is it generating the correct syntax, right? So similarly, we have other test cases as well, where we do testing, and then we use meta prompts for the large language model and few shot examples and some other validation tools to help make sure that Copilot's generating valid queries and accurate queries. And again, like any large language model, the results aren't perfect. Any output generated by a large language model, even Copilot, if we're as awesome as it is, even Wheelie, should be validated by humans, should be validated by rigorous testing. So, we continue to make iterative improvements in Copilot. We've already launched several small improvements to Copilot since the public preview launch on November 15th. We're going to continue to make improvements over time. But I think it's important to sort of realize that with any AI or machine learning application, it requires some experimentation, requires validation, requires evaluation, and iterative improvement over time. Cool. I think we're good. Thank you, everyone, for joining us today.
Thanks, everyone, for joining. All right. See ya.